All right, hello everyone. So today we're going to go over a discrete math problem. We're going to prove that the square root of 3 is irrational. Now I'm going to do this by contradiction. So we're going to suppose that that statement is actually false, and eventually, based on that assumption, it's going to lead us to some type of contradiction when we do the quote-unquote math. So we're going to suppose that square root of 3 is rational. That's contradicting something being irrational. And that means that there's got to be two integers, a and b, such that a divided by b equals the square root of 3. And ab is in lowest terms, where we're going to assume that. In other words of saying that is that the GCD of a and b is equal to 1. Now, if you look at the statement a divided by b equals square root of 3, you can certainly do a lot of things with it. One thing is I can square both sides, and you get a squared over b squared is 3, or a squared is equal to 3 times b squared. And basically this implies that 3 divides a squared. Yeah, if you tell me a number, in this case a squared equals 3 times another number, then 3 has to divide it. Now, what I'm going to do with that is as follows, and I'm not going to prove this, but you can certainly look up the proofs here, but there's something that says that if you take 3 and it divides a squared, then 3 divides a. Okay, and several ways of proving that. Like one way is using like modular, like arithmetic and such. But anyways, I won't prove that. I'll just state that. So we have that 3 will also divide a. 3 divides a square implies 3 divides a. What would that mean? Well, that means that a is equal to 3 times some integer. Call it s. So s is an integer. And well, since you have that a squared equals 3b squared, and then if you replace the a with 3s, you get 3s squared equals 3b squared, which would mean 9s squared equals 3b squared, or b squared equals 3s squared. Well, this means that 3 divides b squared as well, and by what I said earlier about 3 dividing a squared, 3 divides b. So b equals 3 times some integer r. But see, this is a contradiction, because a and b were assumed to be in lowest terms. So there's no divisor other than one that's common to both of them. So therefore, because both of them are 3 is a divisor for both. Okay, so that is a contradiction. And what does that mean? Well, that means that my assumption cannot be true, which was a over b equals square root of 3. So that assumption directly led to this contradiction. Okay, so that's a contradiction, and therefore square root of 3 is irrational. Now, there are other ways of proving this statement. You could use like the rational roots theorem for one thing. The other thing you could use is starting from like this step, you could use the fact that every number, every integer is factorable into its primes. And there's and I don't have time to go over that proof, but yeah, there's another way. Another proof goes over that, assuming that a and b can be factored into primes, and it looks at the number of like factors in each when you square a and b. So anyways, I'll let you look into that, but that's how that would work in this case. So thank you for your time. Appreciate it.